Hello everyone, welcome back to my YouTube channel. This is Rachana from Sri Venkateshwara College of Engineering, pursuing second year in BE Computer Science and Engineering. Today in this video we are going to discuss on the topic Poisson distribution and its applications. So first let us see Poisson distribution. The Poisson distribution is a probability distribution that describes the number of events occurring within a fixed interval of time or space. Given that these events happen independently and the average rate of occurrence is constant, it is named after the French mathematician Simon Denis Poisson. The distribution is widely used in fields such as physics, economics, biology, and engineering to model random events that occur in fixed intervals. Next, let us see Poisson distribution formula. The probability of observing exactly events in an interval is given by the formula P of x equals k equals fraction of slash lambda power k e power minus slash lambda into k naught, where P of x equals k is the probability of k events occurring. Lambda is the average number of events in the interval. The rate parameter is the base of the natural logarithm, approximately 2.71828. K naught is the factorial of k. Next, what are the key characteristics of Poisson distribution? There are four key characteristics: discrete distribution, memoryless property, rate parameter, non-negative. First, let us see one by one. Discrete distribution. It ideals with discrete events, means countable occurrences. Next, memoryless property. The Poisson distribution assumes that the event occur independently and have no memory of past events. Next, rate parameter represents the average number of events in the specified time or space interval. Next, non-negative. The possible outcomes can only take non-negative integer values like k equals 0, 1, 2, 3. Next, what are the applications of Poisson distribution? First, let us see queuing theory. It is used to model the number of customers arriving at a service point. Example, a bank, call center, or hospital emergency room within a specific time period. For example, the number of phone calls to a call center per minute. Next, traffic flow and accidents. It models the number of cars passing through a toll booth or the number of traffic accidents occurring at a particular intersection detected at a given time. Next, let us see in biology and medicine. In biology and medicine, the probability distribution is used. So let's discuss in the biology and medicine fields and in physics fields. In biology and medicine fields, let us discuss in mutation rates and infectious diseases. Mutation rates, the number of mutations occurring in a given stretch of DNA in a certain time or space. Next, infectious diseases, modeling the number of new cases of a disease in a specific population over time. For example, the number of people infected with a virus in a particular region. Next, in physics, radioactive decay, the number of decays of a radioactive substance in a given time period follows a Poisson distribution. Next, photon counting, the number of photons detected in a detector at a fixed period of time. Next, in the fields of economics and finance, inventory management, and natural phenomena. So, let's discuss in economics and finance. It can be used to model the number of defaults in a portfolio of loans or the occurrence of rare financial events like bankruptcies. Inventory management. In cases where items are sold independently and sporadically, the Poisson distribution can model demand for products within a specific time interval. Next, in natural phenomena, it can be used to model rare events such as the occurrence of earthquakes in a region or lightning streaks in a certain area during a specified period. Next, in telecommunications, packet arrival in networks. The number of data packets arriving at a router or switch in a given time period can follow a Poisson distribution. This is especially relevant in network traffic modeling and congestion control. Call center operations. The number of incoming calls to a call center per minute or hour can be modeled using a Poisson distribution. It helps in predicting the staffing needs and call handling capacity. Next, in astronomy, astrophysical events. The Poisson distribution is used to model rare cosmic events such as the number of supernovae observed in a galaxy over a fixed period or the number of meteors observed in a given time window. Next, let us see the example problem. Suppose the average number of cars that pass through a toll booth in an hour is 12. What is the probability that exactly 15 cars will pass through the toll booth in the next hour? Here, using the Poisson formula, P of x equals 14 means 15 cars we have taken x is equal to 15 is equal to slash fraction 12 means is 12 power 15 e power minus 12 into 15 naught. By plugging in the values, we can calculate the exact probability. The Poisson distribution is especially useful in situations where the events being modeled are rare or occur infrequently, but in large number of time periods. Next, lastly, we see the conclusion. The Poisson distribution is a powerful statistical tool for modeling the occurrence of rare or random events over a fixed time of interval of time or space. Its applications are vast and span many fields, including healthcare, telecommunication, manufacturing, finance, and social sciences. By capturing the likelihood of specific events counts, it helps organization optimize resources, predict outcomes, and manage risk effectively. The Poisson distribution is especially valuable when events occur independently at a constant average rate, making it an essential tool in fields that deal with rare or sporadic events. Thank you everyone. If you like